In your LinkedIn, I saw that you said you help stars to fly.
Yes.
What do you mean with that one?
What do I mean by that one? So I help superstars take flight. Yeah. So that's kind of a metaphor, basically. Okay. So they're already hard workers. They're already going to do well. I help them get there.
Oh, nice. And you will help us one day to fly with you.
I hope very much so. Welcome to the E6S Methods podcast with Jacob and Aaron, your weekly dose of tips and tricks to achieve excellent performance in your business and career. Join us as we explore deeper into the practical worlds of Lean Six Sigma, project management, and design thinking. In this episode number 108, we speak with practitioners Hussain Abualkhair and Faisal Aldawood as they share their work with the industries of the blind to reduce manufacturing variation in military parachute bags. Lean Six Sigma, parachutes, and the blind. It's a fact, but not an obstacle. Here we go. Thanks for coming on the show. Before we get into the topic, can you share a little bit about yourselves? Hussain, let's start with you.
Yeah, I'm Hussain Abualkhair. I'm a master's student in industrial and system engineering, and also I'm a master's student in MBA for supply chain management from North Carolina State A&T State University. I received my Bachelor of Science in Engineering, Industrial Engineering from Arizona State University in December 2014.
Congratulations.
Oh, thank you so much. And I just joined the master program January 2015. My focusing area now on operation research. I'm working on managing volunteer for convergence at disaster relief centers. This is my current research.
Okay, great.
Yeah. And I have received, I have certified the Six Sigma Green Belt in March 2015, and I'm expected to certify the Six Sigma Black Belt by December 2016. I'm working on it now.
Excellent. Now, is that certification through the school, or who are you taking that certification with?
The Black Belt?
Both the Green Belt or the Black Belt?
Yeah, the Green Belt, yeah, we got through the school, and it's sponsored by Boeing.
Oh, great.
Yeah. And the Black Belt, no, we are looking for the ASQ.
Okay.
Yep.
So, okay, thanks, Hussain. Faisal, how about you? What's your background?
My name is Faisal Aldawood. I got a bachelor degree in industrial engineering from King Abdulaziz University in Saudi Arabia.
Okay.
In May 2012. Right now, I'm a master candidate in industrial and system engineering also at North Carolina A&T State University. Hopefully, I will graduate in May 2016. And I had several internship opportunity in accounting field and project management, risk management, and also project coordinator. I also got the Six Sigma Green Belt in November 2014, was sponsored by Boeing, as Hussain said. Right now, my research area is about design and manufacturing of radiation therapy devices using 3D printing technology.
Did you say radiation therapy devices?
Yes.
Using 3D? Oh, that's interesting. That's an interesting combination there. So it's basically 3D printed medical devices?
Right.
Okay, awesome. So for your guys, you said Boeing sponsored. Does that mean you did a project within Boeing to get that?
No, we do the project through the school, and this project that we have done with the Industries of the Blind is one of our projects for Six Sigma.
Okay, so this project counted toward your certification.
Yes,
for Green Belt. Okay, so how did the Boeing sponsorship work? Did they provide the training, or the I guess the money to help you get it? How does Boeing sponsor a Green Belt certification?
They sponsored it by paying the university all the fees for this certificate and for the training. Also our professor, Dr. Dimatos. I don't know if you met him in the conference or not.
I don't believe so.
Yeah, he was there. He was with us. He's supporting us all the time. And he was the one who got the sponsorship from them, and he's the one who trained us.
So basically, they took most people when they take training, they they have a company who pays for it, usually the company they work for. So basically he was able to get Boeing to basically donate the money for you to receive the training.
Yep. Yes, actually, for spring semester, Dr. Dematis usually give 1 day training, and after 2 weeks he provide an exam. And also in fall he changed his method to like do real project.
Okay, great. Oh, thank you for that background. So, tell me just a little bit about North Carolina Agricultural Technical State University. It doesn't sound like a industrial and systems engineering school. Can you tell me a little history behind the school?
Yeah, sure. North Carolina Agricultural Technical and State University, they have a great program for industrial and system engineering. Actually, I got my Bachelor in Industrial Engineering was from Arizona State University. And now I'm taking the master at A&T. Arizona State University in Industrial and System Engineering, it was one of the top 20 universities around the USA in industrial engineering.
Right.
But to be honest, like when I came here for the master degree in North Carolina A&T State University, it was like big different. The rank, it's not the same as Arizona State University. You see the rank here, it's about the 60th it's about the 60th, I think, around the US.
Right.
For the program, it's 56th, actually.
Yeah, it's the 56th around the US.
Oh, that's not bad.
Yeah, but Arizona State was much better than this has much better rank than this one. But if you come to the reality, you will find it's not like that. I feel like here it's much better than there. Professors here are caring a lot about their students.
Oh,
they're doing a lot. Like they're working a lot for us, and they're helping us a lot in everything. And the outcome of students, they care a lot about this. Not like there. In there, it's big university. If you go, the smallest class was about 50 students in the smallest class. But here, like, no, our classes it has fewer students, but we have like more like we got more benefits here than there actually.
Excellent. So you're finding you're learning more.
Yeah, I found I'm learning more here.
Excellent.
Especially because our professors are very close to us here. And Dr. Tonya Smith Jackson, she's the chair of the industrial and system engineering at the university. She's doing really a great job helping us.
Well, I just found it interesting that it has agricultural in the name, so I was curious about that, and that sets it apart from.
They have a lot of measures. It's not only agriculture,
right?
It's called agriculture because the base of the engineering is coming from the agriculture.
Okay.
Yeah, and I think it was part of the North Carolina State University.
Oh, okay.
Yeah, and the history, it was like, I don't remember the year exactly, but it was about the African American and how they split from that university, and they were sad, like they opened this university, and it started with agriculture here.
Oh.
Because that they give the name, but we have many majors in engineering, not only industrial and system or agriculture. We have civils, we have mechanical, we have electrical. Yep.
Okay. Hey, thank you for that.
Thank you so much.
All right, so let's talk a little bit more about your project. So go ahead and sort of give me a background. I see you've got, I have your project title as Identifying Variations in the Manufacturing of Parachute Bags. Give me some more. Who were you doing this project for, and what was the problem you're trying to solve?
Here is one requirement for our Six Sigma class. We are a group of five students, and Hussain and other three. We have done we contact with the Industries of the Blind, which is an organization that started in 1933 with only 6 people. Right now they are doing a great business. They locate in Greensboro, so it's make our life easy. It's close to our university.
Great.
And they have an issue with producing parachute bags. they produce it to the military, and they're trying to reduce or minimize the number of to reduce the variation in the bags.
Mm-hmm.
So we contact them to find the solution to them and provide like recommendation to work on it.
Okay.
And as one more important about the company, they have a policy from the government. If you hire one visual person, you have to hire 3 blind person.
Interesting. Okay.
So 70% of the employee are blind, and they have like a mission. They have written in back in the front of the company. It's called "It is fact, but it is not an obstacle."
That's their logo, and it's on a sign out front of their company.
Yes.
Or a slogan, I should say. Yes. Mm-hmm.
Yeah, and here it seems like it tells that it's not an obstacle for blind people to work and have their regular life as other people.
Mm-hmm.
And if you go there, you'll find it's amazing organization. Really, everything there is organized for them, and they are so happy there. Like everything's clean. They are using for sure like 5S there and everything. If you go there, all the equipments are like set and sort very well. Everything's well organized, and also the visual operators or the managers there, they are doing like they are helping them a lot,
mm-hmm.
and they're providing them with everything they need. So this logo was really like has a lot of meaning for them, even not for like other people to see that they know or they can work as
right.
other people. And the other things that if you see, they are manufacturing parachute bags, and parachute bags for who? For the military.
Right.
So many people think that, they are manufacturing parachute bags, so any mistakes or anything will happen that may affect because it may affect the military, like, because this is life and they are flying with those bags.
Right.
Any mistakes on it, they will die. But they trust on them.
Mm-hmm.
And to be honest, in manufacturing the parachute bags, they're manufacturing many things. Not only parachute bags for the military. They providing like some pins, some T-shirts, and like those stuff. They manufacture those stuff for the military. But for the parachute bags, most of the operators there are visual operators.
Okay.
And one of the goals of this project is to minimize this number of visuals.
So you want to get more people who are sight impaired or blind working directly on the parachute bags.
Yeah, exactly.
Excellent. So I see you want to reduce the variation. So specifically, what did you want to reduce the variation in, and why was this causing a problem for the industry of the blind? What was the problem? What was the business problem?
The business is actually lost caused to the organization because the variation occurred in the manufacturing of military parachute bags. So their customer, which are the military, are not happy about the production. But they are doing a good job because it's not like that much variation is out of specific limit.
Okay.
But still, there is a variation.
So they weren't out of spec, but there was variation still.
Yes.
Yeah. Actually, they want to reduce the variation here in the parachute bags because they have a machine in the process for the manufacturing. They have a machine that it does the job automatically, so it doesn't need a visual operator to be there to do this exact process, which is the 4-point stitch process. This is our scope. So they were focusing in the 4-point stitch process. I don't know if they can see or you can see the pictures, the circle picture that has the stitch. This stitch, like it's automatic machine will do it. The operator only need to put the sheet of the parachute bags on the stitching machine, and it will stitch by itself.
Okay.
So they want to reduce the variation because if they reduce it, they will be able to put a blind operator on this machine.
Okay.
So the blind operator will only put the machine, the sheets, and they can have like specific limitations or specific size. So when they bought the build, if you see this is the build there. So when they bought the build, they need to put an exact point so the machine will stitch there.
Okay, great.
You are listening to E6S Methods Podcast, brought to you by E6S Industries. Join us on our website at www.e6s-methods.com. Journey through success.
Hey, Jacob, you remember when you used to work for me?
Sure.
Do you happen to remember how much money you were making back then?
Yeah, I do.
Yeah? And
Yeah.
how much more you're making right now?
I can do the math.
And how about that development plan that you and I put together during that time?
Definitely gave me some perspective and gave me some direction on what I need to focus on. I found that useful.
So far, I have a 100% promotion success rate for those people who are willing to work hard and were willing to work with me to create a customized career development plan, the E6S Pro Career Program. 3 different levels. Promotion and pathfinding level, which is career planning, customized improvement plans, resume refinement, and interview preparation. The next level down is targeted for those people they're just looking to prepare for their next move. And because it really does pain me to see unemployed professionals, I am offering a level called Help Quick, a free one-time resume review and revision for those who are unemployed and in the Lean Six Sigma, quality, engineering, project management, or science fields. So for anybody who wants more details and information, these can be found at www.e6s-methods.com/procareer. And if you're serious about career advancement, contact me through the website. You'll be glad you did.
I can vouch for that.
So how did you start to tackle this project? Now that you understand the scope and what the problem is, what were your next steps?
Our next steps was to collect the data to start the actual measure phase. So our plan is to go to the organization and get some measurement for the parachute bags. We divide our measurement to 8 points for location in the top of the parachute bags and 4 in the bottom. Also, we took this measurement for 3 days. Every day we get 10 different parachute bags measurements.
Okay.
Yeah, and this one was very challenges for us because it was very hard for us to stop the production, and they asked us, the management there asked us not to stop the production.
Right.
Because like take the samples, but don't affect don't affect our production flow. So it was a challenge for us to get samples very fast and get accurate measurements.
Mm-hmm. So were you doing the measurements yourself offline?
Yeah, we were taking because there were some processes are finishing the parachute bag faster than others. Mm-hmm. So we take this gap, and so we could get some samples from there and get the measurements.
Okay. So, considering that he didn't want you to interrupt the process, were you able to learn anything from the operators about their challenges, or were you kind of asked to not bother them at all?
No, actually, they were asking us not to bothering them at all. But in the beginning, we did some interviews. They let us do it, but after that, they told us, please, don't affect them. Let them do their jobs. And even when we are we're taking recording some videos because those videos were going to help us identifying the problem more and review it more to get to understand the problem much better and see the exact problem where it's coming from. So we're recording the whole process. And when we were recording, also they asked us, please don't bother them. So try to make it very fast and try to make it from sides that it's not affect their site.
Okay. So what did you learn from your data collection plan about where to focus next?
Yeah, after we collect the data, we try to get the process capability to see if the process is capable or not. And we found that the left and right side of the bottom side is not capable, and the process is not meet the specification. And also they have a lower process sigma, which is compared to others, compared to other
Right.
location. So that's from that we consider like 2 point or 2 location to focus in, because the variations come from these 2 locations.
Okay. How did you pick those points?
It depends on their process sigma and the process capability. We've done some statistic test, and we found that these 2 has more variation than the others.
Yeah, and actually like that, if you see the process sigma for the right and left bottom side, especially the right side, it was 2.2. And we were focusing on the right side because it was the lowest one. And we believe that if we focus in solving this problem, we could solve the other problems. Because if we could make these 2 sides are like has accurate measurements, we could make the others. Because of that, we just focus on those 2 more than the others.
So now you wanted to focus on that, and you've gotten some video, and I see you have a fishbone here. Tell me a little bit more about how you use the video, how you leverage the video for the project, and then tell me a little bit more about how the fishbone helped you move further.
Sorry, for the video, what was your question?
For the video, just tell me how you used the video and how that helped you. Video is off. I've actually never used video in any of my projects, and very seldom do I have people who have done it. So I think it's a great tool, especially now that we all have video cameras in our pockets. So how did you use this to help with your project?
Yeah, actually the video, like we did it because we were like, we are students and we have a lot of classes and we have a lot of work and school to do. So it was difficult for us to go a lot of the time there. And the other challenge things that was on that time, there were a snowstorm during that semester.
Yes. The very few snowstorms you get.
Exactly. And that affects our visitings to the industry to observe the problem there. And so the video helped us a lot to observe the problem, observe the how operators operate each process and how they go through it. And we're checking everything, how they do the measurements, how they do the points, how they mark the points that they want to stitch. So videos helped us a lot in this problem, and we watched that video for about maybe 10, 20 times.
Right.
We watched it a lot. We watched that video a lot.
So when you were watching the video, were you focusing specifically on the variation here, or were you looking at other things and how they're moving their bodies and, how much distance they need to walk? I mean, what were you looking for specifically?
Exactly. On the video, we were looking for everything.
Okay.
And from that video, we could create a very good fishbone diagram.
Okay.
Because we were looking in how the operator working, how is the environment there, and the method they are using. Are they accurate? What's the standard operation procedures? And what's the limitations they have? And what the specification limits that they have? And how operators are feeling while they are working. All those factors, we knew them from the videos.
Also, the video is shown to the listener or to the management. What is the 4-point stitch machine? So if you tell anyone 4-point stitch machine, he doesn't understand. So we show that picture or that video, and like they said, picture worth 1,000 words.
Right. Okay, so you use the video to help you create this fishbone diagram?
Exactly, and yep. And also to show how the 4-stitch point is it's very easy for any operator, even visual or blind, any one of them, they can operate this one. The only things that they need a specific limitation or specific template that they can put the sheet on it and start stitching.
Right. Okay. Tell me a little bit more. This is one of the most involved fishbone diagrams I've ever seen. So everything on here came from the video, or was some of it brainstormed because of ideas that you've had, or is all of it from the video?
No, some of them were brainstorming.
Okay, that's fine. I'm just curious how, and I'm asking for an honest answer. I'm on record as having the fishbone be my least favorite tool, but I'm always curious as to how other people feel about it. How did you feel the fishbone helped you in going forward with your project?
It helped us organize our brainstorming.
Okay, great.
And this is the most things that it helped us on it. And we find all the possible causes of that problem from this fishbone diagram. Mm-hmm. Because if we have another method, such as like brainstorming in any regular paper, or we will lost with it. The fishbone helped us that we see all the problems that operators, or all the possible causes of the variations that operator could do. Mm-hmm. And the other things also from the methods. And those two, like if you see them, we put them in red, because those the most two things that we focused on there.
Okay, great, thank you.
You're welcome.
All right, so now you've gone through your measure.
Sorry, Aaron, for you.
Go ahead.
Why you feel it's the least?
Well, in a lot of manners, I think usually, it's almost always applied wrong. Often the fishbone, sometimes when you're reacting to a problem, right? So this would be a root cause analysis for a very fast, or for an error that occurred. Usually somebody's trying to defend themselves, but they're not actually using it to come up with anything. So often it's not used to properly brainstorm, but it also is just categorizing things that people already thought about, and then often it doesn't. It's sometimes just used in presentations, and you may not. In the corporate world, PowerPoint has gotten out of hand, and maybe you're seeing that in the university now too. But oftentimes it's less a tool that helps you find direction, and more of a tool that just makes better PowerPoint slides. That's my feeling on it.
Yeah.
And I hope you guys, when you're in the corporate world, don't get sucked into PowerPoint. But it actually is really, really problematic for business, in my opinion. That's a whole different topic, though.
Mm-hmm. No, but actually, for me, like even for Faisal, we used it in two other projects, mm-hmm. And I used it especially like when I was with the team on the team meetings. We used the fishbone diagrams to help us organize. Like we felt it helped us organizing the ideas, mm-hmm. more than showing it on the presentations. But when we come up with it, it was only like for us in the beginning. And when we discussed it with our professor, he liked it a lot, and he said, "This should be in your report and in your presentation." And he asked us like to make it much better than.
Also, I feel the fishbone diagrams is showing all the possible cause for the problem. So mm-hmm. there is no other cause out of this diagram. So your job is to narrow down the possible causes and to find the exact cause for the problem.
Right.
What other like methods you prefer for brainstorming? Sorry for the question.
No, that's fine. Often
we are still like students, and we really like to learn from people who like you. Your master black belt.
So there's many brainstorming ones. One of my favorites is more often is silent brainstorming, but which is maybe using the affinity, and sometimes the affinity and fishbone are used together. But so this is good as a brainstorming tool, but often I find that it's used in sort of the opposite order, where people have brainstormed and then they stick it into a category, whereas the benefits come from, I believe, having the category first. That way you drill down deep into the brainstorming within each category, and it looks like you guys did a lot of that. And some people just it can be too chaotic just looking at it. And there are people I know who prefer to look at it as like an outline in a list rather than as a in the fishbone. So everybody has their preferences. Personally, I've never really found much use for it, but that doesn't mean it's not useful.
Thank you.
Oh, that's no problem. It's just, and you'll find when you get out there that you're going to have certain tools that you're going to commonly use. I typically rely more on the process map to get into a lot of detail on the process map, yep, and not so much on Fishbone.
You are listening to E6S Methods Podcast, brought to you by E6S Industries. Join us on our website at www.e6s-methods.com. Journey through success.
Did you know E6S Industries delivers custom training? We'll customize a program to meet your unique continuous improvement needs. We're also experienced keynote and motivational speakers to professional organizations and universities. Contact us on our website, www.e6s-methods.com, and let us help you chart your journey through success. Okay, so you've got your data and you've got your data collection. What do you have? Now, what did you learn from that? You've got your analyze phase is coming, and I see you've got some additional measurements here that show some variation that changes from day to day?
Yes.
And what can you tell me about that?
Like I said before, we go 3 times. Each time we get 10 measurements. Actually, it's this from day to day is that the data where we collected is for one operator.
Okay.
So the problem with the operator, he might not does not know the procedure for the work or how it's done, or he's not expert, or there is no specification limit. He work on it.
Okay.
So the problem come from the operator. Maybe it's not about the procedure. Maybe about his mood, or maybe he feel fatigue or something.
Okay.
So all come from the operator accuracy.
Interesting. So even though it's an automated machine, there's still something day to day. If the operator maybe is tired.
No. Sorry, it's not. It's not automated machine, because the operators here the automated machine only was for the 4 stitch point.
Okay.
Okay, the other processes, it's automated, but the operator need to move the sheets and need to hold 2 pieces together and put them on the machines.
Okay.
So they doesn't know they doesn't put on the exact measures or the exact, because there is built and there is 2 pieces. We bought 1 piece on the upper side and other piece on the bottom side,
mm-hmm,
and then they stitch the belt from the upper side and from the lower from the bottom, also for the bottom side. So they were moving the sheets up and down to stitch, and here's the variation coming from. They are not focusing on the variations that coming from this. We are not focusing on the variations that coming from the 4-point stitch that our focus on. We found that the variation coming from the process before that process.
mm-hmm.
So because that we were focusing in the first machine. The first machine in the whole process, it was doing 4 different processes, and all it's done by 1 operator.
Okay.
And this operator who has this, like the if you see the graph for the box plot of bottom left measurement,
mm-hmm,
these are the measurements for that operator.
Okay.
And he was the same operator. Like we were really shocked that the same operators with 3 different measurements for each day.
Right. So, but yeah, so I mean, pretty tight variation on the first day, but I mean, I guess that could have just been a good day, or maybe I see it's a little bit non-normal, so it could have been maybe he was butting up against a certain upper limit or something like that too. So it's just kind of interesting.
But also, even for the first day, if you see, the process is not. Yeah, it's not centered there.
Right.
If you see the mean, it's in the bottom there.
Mm-hmm.
It's not like the third day. The third day, it seems like the mean is better than the first day.
Right.
But the variation was bigger.
Okay, so day to day you have the same operator showing quite a bit of variation. So, what sort of where did that lead you next? What are the next steps?
The next step is to really narrow down the possible causes, and we found there are two. Beside the operator accuracy, there is a standard operating procedure. So there is no procedure for the employee where he should put the sheets to start or to point the location that he should or she should stitch on it. So there is no procedure show for them. So this is what we come up with the causes for this problem.
Okay.
After we narrowed the root causes and we found that the operator's accuracy and the standard operation procedures that operators are not following, or they doesn't have, to be more clear, they doesn't have standard operation procedures. After that, we went to the improve phase.
Okay.
In our improving phase, we couldn't we came up with three different solutions. But we couldn't implement those three solutions there because the time, and as I told you, it was challenging for us, the stone and also the measurements, the management. We gave them the reports and we gave them a full plan how they implement the solutions and what the possible outcomes and how they how they improve those. How they improve or solve this problem.
Okay.
So the first solution we came with was for this first machine. We came with the idea for making borders and groves. Sorry. So the border would be on the sides, and the groves would be for stitching the bolts. So the operators, when they put the sheet on the table, they will have those solid borders on the side, on the corners. So the sheet won't move, and that will help them to be specific in stitching.
So it's basically a fixture. It keeps everything in place, and then by feel they can know if they're in the right spot.
Exactly, and here we'll come again here on this one. This solution talking about the first machine, not the 4 stitch point.
Okay.
And because for the 4 stitch point, it's not that hard. We will just put the same solid borders there, so that the sheets doesn't move, and there will be no variation. So the machine will stitch by itself.
Right.
So our problem now in the first machine, those solutions are for the first machine in the whole process.
Okay.
And this solution was for visual operator. So visual operator will still operate in this machine, okay, but they will do very accurate measurements, and the variation will be reduced here. So when they move the sheet to the 4-point stitch, a blind operator can work on that machine.
Okay.
The second solution was dividing that process to 2 different processes. Not the process, sorry. We add another machine, and the 4 processes that were stitching by the first machine, we divided into 2 machines to make it easier, and the operator doesn't need to move the sheets from each side, like stitching the upper side, then move it to the bottom side and stitch again. So the first machine will stitch only the upper side. The second machine will stitch only the bottom side. And both of them will also implement the first solution that we have, which is the solid or the fixture process. The solid border and grooves,
Right.
And when we do it like that, it would be easy for blind operator to operate those 2 machines, because here the blind operator will only put the sheets and put the upper piece there on the upper side and just move the machine to stitch. So it won't be hard for blind operator to operate this process.
Right.
In this solution, we save them like three operators, three visual operators, because the first machine will have, two visual operators, because instead of making the first machine for visual operator, a blind operator will be able to process that machine.
Mm-hmm.
And also, when they move to the 4-point stitch, another blind operator will operate on that machine too.
Excellent. Okay.
Yeah. The third solution was keeping the whole process as it is and improve the operator accuracy. But not only improving the operator accuracy, but also we show them the specification limits on the board. Like we just even mark it with a pin that the visual operator can see it. Say, okay, I have to put the sheets here and I have to stitch from here to here, not moving the upper side, the upper piece or the bottom piece. And also we need here to improve their accuracy by train them more. So training will be part of this solution too.
Okay. So that, it sounds like, each of these solutions can be implemented, but maybe at different times. So your third solution is something they can do right now, yes. And they don't have to buy any additional equipment. They just need, to do a couple things a little bit differently in the meantime.
Yep.
Perfect. All right. So you left them with these recommendations, and then were you able to see whether or not they implemented anything and how things went after that?
Yeah, actually, we just talked to our professor today. We were with him, Dr. Dimatos. And he's the one who contacting the industries of the blind there. And he told us that they still reviewing the reports and they will implement it when they have the time to do it. And we may they may ask us to come there and implement these solutions, but they still because if you go there and see the manager there, the president of the IOE, he's working even in the field. He's all the time there with the operators and solving their problems, and he doesn't have any time to even look at those. But we're still waiting for that one. And Dr. Dimatos, he told us that they like the solution very much and they liked everything that we have done for them, and they still maybe they will contact us this by the end of this semester to do it because we have now we will finish this semester on the beginning of December. And after that, we'll have a vacation for the Christmas and for beginning of January. So we may work on the project, complete the project on this period of time.
Yeah. Also, they deal with the mass production there, and they have to meet the target. So any stop in the production line or taking sample may affect the targets.
Right. So unfortunately, that's pretty common. That often companies can't find the time to make the necessary improvements that will, help them.
Yeah.
It's a hard balance to keep.
Yes.
All right. Is there anything else? Any other questions that I forgot to ask?
This was almost all about our project. We were very exciting doing this project. We have learned a lot from this project. It was really new experience for us. We learned a lot, and we are ready for the next project.
Excellent. Well, Congratulations, and thanks again for coming on. If anybody wants to contact you, what's the best way they can do that?
They can contact us by phone, by emails, or through LinkedIn. We are available everywhere. And
anytime.
Anyone are welcome to if they have any questions or they want us to show anything. They are more than welcome, really.
Excellent. Thank you very much.
Thank you so much, Aaron. It was our pleasure talking to you and be your guest in this show, and we appreciate it. Thank you so much.
Thank you.
Thanks for listening to episode 108 of the E6S Methods podcast. If you regularly tune into the podcast, do us a favor. Go to iTunes right now and leave a review so we can move up in the ranks and attract more of the guests that you'd like to hear from. And if you know somebody who would make a great guest on the podcast, be sure to let us know. Follow us on Twitter at E6S Industries or start a conversation in our discussion group. Both Jacob and I are on LinkedIn, and we accept all invitations. Don't forget, you can find notes and graphics for all shows and more at www.e6s-methods.com. journey through success. If you're not climbing up, you're falling down. How do you pronounce your name?
I'm Hussain Abualkhair.
Hussain Abualkhair. Okay,
Yep.
And who else do we have?
Faisal, last name Aldawood.
Faisal, okay. Faisal Aldawood. Okay, Aldawood. I'm probably going to say it incorrectly, but I'm sure you guys are used to that by now.
It's okay. We always have this problem.
Yeah.
No problem.